This video covers the following topics. First, we will give a general introduction. Then, we will explain each point in detail. One-point perspective is a term that refers to a drawing technique in which all objects appear to converge toward a single vanishing point on the horizon. Vanishing point is a term that refers to the point in linear perspective where parallel lines receding into the distance appear to meet. When we say that an object is facing straight ahead relative to the observer's shoulder, it means that the parallelism of a certain face of the object matches the parallelism of the observer's shoulder or the camera. In other words, this refers to the alignment of angles between the lines. In one-point perspective, a particular line is at the same angle as the shoulder. The key point here is that it is about positioning the cube to face the front, rather than the cube facing the viewpoint. In this case, it means that one-point perspective and two-point perspective are mixed together. The natural perspective of a human is close to three-point perspective. Let's take a look at the advantages and disadvantages of one-point perspective. First, here are the advantages. It is easy to create drawings using one-point perspective. It can also emphasize a sense of movement and dramatic effect. Next, here are the disadvantages. It is difficult to use for curved objects. It cannot effectively convey the feeling of looking up, looking down, or viewing from an angle. For example, even if we add depth to a circle in this way, it does not resemble the sphere we envision. As Rob Lee would say, it creates a rigid outline and becomes something else. It is important to be aware of the difference between constructing a scene and capturing what we see. In the former case, there are many considerations to keep in mind. I will explain what one-point perspective is. One-point perspective is a term that refers to a drawing technique in which all objects appear to converge toward a single vanishing point on the horizon. Vanishing point is a term that refers to the point in linear perspective where parallel lines receding into the distance appear to meet. For example, this photo of the railway closely resembles the concept of one-point perspective. The tracks appear to curve and converge toward a single vanishing point. You might think, one-point perspective seems easy. However, when you think more deeply, many things remain unclear. For example, the object is directly facing the viewer, only one set of lines intersects, and there are areas in one-point perspective where the size changes but doesn't converge. These are just a few of the confusing points for beginners. In this session, I want to address these questions from a beginner's perspective. I will explain what it means for the object to be directly facing the shoulders. First, by shoulders, we naturally mean human shoulders. It could be a robot's shoulders, but let's stick with a human for now. The object refers to the scene you're viewing or the item you want to draw. For example, let's assume a cube is positioned directly in front of you like this. If a person were viewing this scene, how would their shoulders be aligned? Since this is the Blender software, the camera serves as the viewpoint rather than a human. If you were to view the scene from the side, it would look like this. When aligning the camera's position with the human's shoulders, it looks like this. In short, the human shoulders represent horizontality. The horizontality of the square camera is expressed in the same way as the human shoulders. This helps clarify the explanation of one-point perspective, where the object is directly facing the shoulders. It's even easier to understand when the object is a cube. Essentially, the parallelism of one face of the object aligns with the parallelism of the observer's shoulders or the camera, meaning the angles of the lines match. When illustrated, it looks like this. The angle of the horizontal lines of the cube observed matches the horizontal line of the observer's shoulders. Now, let's consider cases where they do not match. For example, this scenario illustrates what is known as two-point perspective. This picture plane demonstrates this form. Unlike the previous example, the surfaces of the objects we see are not parallel at the same angle. To make it clearer, a comparative diagram can be created as follows. I believe this clarifies that in one-point perspective, the key point is that the object is directly facing the shoulders. Conversely, this means that you cannot construct a form where it is not facing directly. In two-point perspective, there is more freedom to move left and right, while three-point perspective allows even greater freedom of movement both up and down. I will explain the mystery of diagonal lines in one-point perspective. For example, if we place the two cubes from the previous screen side by side, diagonal lines become apparent. These diagonal lines seem to contradict the explanation that the object is directly facing the shoulders. When illustrated, it looks like this. The important point is that diagonal lines also appear in one-point perspective, meaning not everything is aligned at the same angle as the horizontal lines of the shoulders. While this may seem obvious, there are times when its significance is not fully understood. First of all, even in a frontal view, there are lines that are not horizontal. In other words, vertical lines exist. These lines extend vertically and are not at the same angle as the horizontal line of the shoulders. In other words, there are lines at 90 degrees, not 0 degrees. Once you understand that in one-point perspective a certain line is at the same angle as the shoulders, it becomes easier to accept that other lines can be at different angles. In the three cubes mentioned earlier, there is always at least one side with lines at the same angle. No matter where you place the cube, there will always be at least one line that is parallel to the shoulders. The key point is that the cubes should be arranged to face the front, not necessarily that they are oriented towards the viewpoint. Of course, the cube positioned directly in front of a human or at the center of the picture plane must face the viewpoint, but this is not true for the others. Additionally, it's worth noting that the object at the center of a one-point perspective does not have depth. When the cubes are appropriately placed, there will always be lines that are parallel to the shoulders. Appropriately simply means positioning the cubes to face directly forward. However, it remains a mystery where the front is and where it is not. For instance, in a card game, a card has a front and a back, with the side featuring an illustration being the front. However, in the case of a blank card with nothing drawn on it, either side could semantically represent the front. The important point is that we do not assign meaning to the front and back, rather, the fact that it is simply parallel to the shoulders indicates the front. In the case of a cube, if a face is not parallel to the shoulders, it is considered not the front. For example, a die has faces numbered from 1 to 6, and any face that shows lines parallel to the shoulders can be treated as the front. For example, a case that is not the front would be arranged like this. In this situation, one-point perspective and two-point perspective are mixed together. The typical human viewpoint is neither strictly one-point perspective nor two-point perspective, rather, it is closer to three-point perspective or a combination of these. However, even when this is said, it often raises questions in the minds of beginners like myself. Let's imagine for a moment, suppose there are 10 dice on a table. How many of those dice would be facing directly towards us? It is possible that, by chance, 1 or 2 dice might be facing directly towards us. However, the majority would likely be oriented at some angle. For example, in a world defined solely by one-point perspective, a scene like this could be constructed. Essentially, it would be an image with no freedom of movement left or right, or up and down. Such a scene is rarely encountered in reality. If we were to construct a world defined solely by two-point perspective, it could look like this. However, there is something unnatural about this as well. In our everyday experiences, don't we often look up at or down at dice more frequently? For example, when looking down at the dice on the table, as in three-point perspective, it might look something like this. While having the face showing one aligned like that is a bit unnatural, aside from that, it is a plausible scene. It's important to note that mastering one-point perspective does not automatically enable you to draw any scene naturally. In the real world, three-point perspective is more common. While there are scenes, like train tracks, that closely resemble one-point perspective, they are rare. When we construct images through imagination, it becomes crucial to deeply understand the intent behind choosing one-point perspective. I will explain the advantages and disadvantages of one-point perspective. First, here are the advantages. It is easy to create drawings. It can emphasize movement and drama. One could say it aims for simplicity in focusing on the subject and impact in terms of emphasizing depth and perspective. Next, here are the disadvantages. It is difficult to use for rounded objects. It cannot effectively convey feelings of looking up, looking down, or viewing from an angle. The compositional freedom is more limited compared to other perspective techniques. Additionally, it is challenging to add depth to the central subject that you want to highlight. For example, there are effect lines that utilize the lines of one-point perspective. With only one vanishing point, focusing on that single point creates an effect that draws the viewer's attention to that specific area. What does it mean to say that one-point perspective cannot be used for rounded objects? One-point perspective is primarily a technique for emphasizing the depth and perspective of linear objects, making it unsuitable for curved shapes like spheres. Instead, more complex perspective techniques, such as three-point perspective, need to be utilized. For example, adding depth to a circle in this way won't create the sphere we envision. As Robbie Lee puts it, a sharp outline forms, turning it into something else. In contrast, a cube made entirely of straight lines poses less concern in this regard. Moreover, even in one-point perspective, it doesn't mean that everything is constructed with straight lines facing directly forward. There are techniques to deliberately create the front using diagonal lines. It's perfectly fine to use slanted lines or rounded objects instead of sharp corners. However, one must consider that the depth will become more contour-like in such cases. For example, this star shape appears to have no lines parallel to the shoulders. However, every star shape is facing directly forward. The important thing is whether the object is facing forward, not whether there are parallel lines at the same angle as your shoulders. For example, the cube on the right is not facing your shoulders, but it is parallel in the same way you are. The cube on the left is facing your shoulders but is not parallel. For example, if you try to give depth to a star-shaped object that has no parallel lines, it would look like this. You can also construct a star using many diagonal lines and curves, but in that case, it's challenging to achieve this solely with one-point perspective. It's necessary to use other perspective techniques as well. For instance, a star with such curvature is difficult to construct strictly using only one-point perspective. Fundamentally, it can be said that constructing curved, nonlinear shapes accurately using perspective is challenging with any perspective method. This is not just a problem with one-point perspective. Instead of trying to complete everything from start to finish using only perspective, it may be wiser to use perspective as a guide or rough sketch to grasp the overall sense of size and three-dimensionality. In that sense, understanding everything in a cubic way and grasping the size in that context is very useful. Simply comprehending things in a cubic manner is not particularly difficult with one-point, two-point, or even three-point perspective. If you want to know the size of a sphere in detail, it might be more effective to create it in 3D to establish a sense of size. Creating analog or digital perspective sketches for a spherical form one by one does not seem wise to me at this point. It might be a technique necessary for those engaged in certain artisanal work. Next time, I plan to explain how to construct a cube using one-point perspective. For instance, after drawing the front face like this, we will tackle the issue of how much depth to set, which involves the so-called vanishing point of the diagonal line. Please subscribe to the channel and give us a thumbs up.